Okay, so let's take a look at ASM 100. You start making assembly code. There's some software to install. And then you create this program, hello.asm. As always, you start with a hello world program, and this is what it looks like. You have a text section where the assembly code is going to go, and here's the start marker, which is where the program starts. That's the entry point. There's going to be a global object called start, and there it is with a colon. That's a memory location. And now we just execute some commands. So we move EDX. I'm writing Microsoft Assembler in the Intel syntax, so it's source destination, the opposite of what we were just talking about before with Linux. So this is, you can tell this one over here has got to be a source, not a destination. So that's the other way. So it moves length into EDX and message into ECX, and those are from the data section. The message is this, it's hello world, and then at 1013, that's a line feed carriage return. Or I think it's what it is. That's going to go to a new line. And the length equals the current location minus the address of message. So that's going to calculate the length of this. Those are these two variables. So it's going to put one of them in EDX, one of them in ECX, one in EBX, which is the device to write to, which is 1, and then 4 in EAX, which is the syscall member. And then it's going to do an int 80. This is how everything works in assembly. You have a syscall. There are just certain kernel functions available. The C library functions are available, and you call them, and you specify with these parameters which one you're going to do. So this is all specified in a tutorial, which is here. But here's the first few syscalls: exit, fork, read, and write. So syscall 4 is write, and here's your parameters. EBX is the number of bytes to write. ECX is a pointer to the string to write. EDX is the size. Oh, this is the device to write to. Standard output is 1. So this is what device to write to. This is the pointer to the start of the string to write, and this is how many bytes of string to write. So that's what I've done here. EDX is the length, ECX is the message, EBX is device number 1, and EX is 4. Then you call int 80. That will print that message on the screen. And this will exit. Remember, syscall 1 is exit, and the only parameter is, all you need to specify is 1 and call this. So this is going to do the C library call of write to the screen, and this is going to do exit. So you compile that thing up here with NASM minus app. That'll compile it to object code, and this will link it LD, making 32-bit object code. And I've already done that, I think. So there it is, hello. It prints hello world. All right. And this one also prints square root of 4, which is a little screwy. So I must have compiled another one later. Let's just compile this one, NASM elf32. All right. And then load it, link it with 386 libraries. Now when I run hello, it just says hello world. Okay, so this is the simplest program you always start with. So now you know how to write to the screen with syswrite. All right, and there's exit, and there's the data section. So that's the general structure, and here's the carriage return and line feed. That's what the 10 and 13 are. So that's the hands-on project, and I highly recommend looking at this tutorial. This tutorial will teach you a lot more. It's very nice. I've learned a lot of languages from this tutorial's point. Learned COBOL and other languages here, and they have a nice little description of these things. So read this like a textbook. It's real short and easy, and then you can get points by answering these questions, which just check to see that you've understood those things. And you don't have to do all of these if you don't want to, although I recommend it, because a lot of extra credit, like there always are. I only require you to do 20 points of this stuff, and there's 49 extra if you do it all. So that's the summary of how to do this kind of assembly line coding. And then you can do some more hands-on programs here. So you can create this head request. The head request has to have this line, and then a blank carriage return, a line feed. And if you get it correctly, you can send it up to my server, and it'll be a valid HTTP request, and you'll get an HTTP response that contains the flag. And here's another one. You can make a get that constructs this get request. with these 3 lines exactly like that. And when you get them right and send it up to my server, again, you'll get a flag. And here's one where you'd actually have to make a loop in assembly code. You're going to send up data, and you're going to send a variety of gets to it. See, get p equals password 0, password 1, password 2. Now, you could just literally change that one by one and run the program many times, but if you use a loop, then it's easier. You can loop through like we talked about. You can make a loop that tries various passwords until you get in. And when you get the right one in there, you'll get a flag. And here's another one. We have to make a loop. So that's a bit of practice coding stuff in assembly that you can do. So let me stop this recording.